A milling machine slide of weight equal to 20 kilonewton is raised up by a single start square thread screw of 50 mm with a pitch of 5 mm, maximum speed equal to 600. So we have given the weight here. We have single start, therefore pitch is same as equal to lead is equal to 5 mm and the outer diameter is equal to 50 mm. The thrust collar of a screw has an inside diameter d1 and outside diameter d2. So from this we can calculate the mean diameter of collar. The coefficient of friction between the nut and the screw is 0.12, that is value of mu is given, and between the nut and collar, that is mu c, is given as 0.1. Power you have to find out. Power is simply equal to the product of 2 pi n into total torque T divided by 60. For this one we require the rotational speed, and he has given the value of velocity. Velocity in the case of screw is same as L into N divided by 60. The torque required to raise the load is W into dm by 2 into tan of 5 plus lambda plus V of mu c into Rc. So first we calculate here the torque, then we calculate the value of N, and finally we'll calculate power. We have given here a single start thread, and therefore we have lead is same as equal to pitch is equal to 5 mm. Outer diameter is given as 50. If we know the outer diameter, then we can calculate the mean diameter as do minus p by 2. This time we have do is equal to 50 minus 5 by 2. That is equal to 47.5 mm. The load W that we want to lift is equal to 20 kilonewton. So we have W is equal to 20 kilonewton. Mu c represent the friction between the nut and collar is 0.1. And mu represent the friction between the nut and screw is 0.12. Then we have given the data for collar. We have inside diameter D1 is equal to 30 mm and the outside diameter D2 is equal to 60 mm. So we can calculate here the mean diameter of collar, that is same as equal to D1 plus D2 divided by 2. That is we have 30 plus 60 divided by 2. 90 divided by 2 is same as equal to 45 mm. For calculation purpose we required the mean radius of a collar. So mean radius of collar is Rc is same as diameter of the collar divided by 2, which is equal to 45 divided by 2 is 22.5 mm. Then we require the angle phi. Phi value we can obtain by using the value of mu. So we have tan phi is same as equal to mu. In this case we have phi is equal to tan inverse of mu, tan inverse of 0.12. So we get the value of phi is equal to 6.843. Then we require the value of lambda. So in this right angle triangle, we can find out the value of lambda by taking tan. So we have tan of lambda is lead divided by pi dm. So we have this time the pitch is same as equal to lead, and we have lead is equal to 5. So we have 5 divided by pi, and we have mean diameter is equal to 47.5. Substitute this and find out the value of lambda. So we have lambda equal to 1.92. Now we know the value of W dm tan of phi plus lambda. Mu c is known, Rc is known, W is known. So we can calculate total torque required to raise the load will be equal to W, which is equal to 20 kilonewton is 20,000, which one is common to both. dm by 2 is same as 47.5 divided by 2 into tan of phi. We have phi is 6.843 plus lambda. Lambda is 1.92 plus we have mu c. Mu c is equal to 0.1 multiplied by Rc. Rc we get 22.5. Find out the value of torque Tr. We get a torque equal to 118,220 is Newton mm. That is equal to 118.22 Newton meter. Now the torque is known, so we can calculate here the value of n. Velocity v is given as 600 mm per minute, so we have 600 mm per minute. L you have to take in mm, that equal to 5 into n. Now this time the unit is match here. L is mm and n is revolution per minute is per minute. So unit is matched. So we have 600 divided by 5. In this case we have rotational speed will be equal to 30 rpm. Finally we can calculate power. Power is same as equal to 2 pi into rotational speed equal to 30, and we have torque you have to use in Newton meter is 118.22. Whole thing is divided by 60 is 371.4. That will be watts. A machine slide weighing 4 kilonewton is elevated by 2 start square thread. So we have given here 2 start square thread of 40 mm diameter, that is the DO is equal to 40, pitch is equal to 6 mm at a rate of 0.6 meter per minute. That is 600 mm per minute. That is value of velocity is given, which is L into n. So n is indirectly known to us. Coefficient of friction is 0.12. Calculate the power required to drive the slide. The end of the screw is carried on the thrust collar of 30 mm inside and 50 mm outside. Only one value of coefficient of friction is given, so you have to take this value as same as equal to mu c as well as mu. The collar dimensions are given as d1 and d2. From this we can calculate mean diameter. We want to calculate here power, so again we have power is equal to 2 pi into rotational speed n multiplied by torque required Tr divided by 60, and we have velocity is mm per minute will be L into n, and the torque required to raise the load is W into dm by 2 into tan of 5 plus lambda plus mu c rc into W. One by one value will collect here, and then we'll find out Tr, then we'll find out n, finally we'll calculate power. Since we have given here the 2 start thread, in this case we have lead will be equal to 2 times of pitch, that equal to 2 times, and we have pitch is equal to 6. So we have lead is equal to 12 mm. The weight W is given, that equal to 6 kilonewton. Outer diameter DO is known, that equal to 40 mm. So we can calculate here the mean diameter of the screw as DO minus pitch divided by 2. That is we have 40. Pitch is equal to 6 by 2. So 40 minus 3, that equal to 37 mm. Only one friction is given, so we have mu is the same as equal to mu c is equal to 0.12. And we have given here the collar dimension, d is equal to 30 and d2 is equal to 50. So we have d1 is equal to 30 mm and d2 is equal to 50 mm. So we can calculate here the mean diameter of collar will be d1 plus d2 divided by 2. That is we have 30 plus 50 divided by 2. 80 divided by 2 is equal to 40 mm. But in calculation we required RC. So we have radius, mean radius of collar is same as equal to mean diameter of collar divided by 2. That is we have 40 divided by 2, which is equal to 20 mm. Then we require the value of phi. So we have tan phi is same as equal to mu. In this case we have phi is equal to tan inverse of mu, and we have mu is equal to 0.12. So we get phi equal to 6.84. Then we require the value of lambda. We have a standard procedure to calculate the value of lambda, that is tan lambda equal to L divided by pi dm. This time we have lead is equal to 12 divided by pi, and we have mean diameter of the thread is equal to 37. Solve this and you can obtain the value of lambda is 5.894. 4. So each and every term is known now. We can calculate TR. So we have W is common and we have W quantity is same as equal to 6 kilonewton. 6 kilonewton is 6000 into dm by 2. We have dm value is 37. So we have 37 divided by 2 into tan of phi. Phi is 6.84 plus lambda is 5.894. 5.894 plus we have mu c is same as equal to mu is 0.12 into RC, that is the mean radius of collar, is 20. From this you will get the torque, which is Newton mm, is 39374 is Newton mm, is same as equal to 39.374 Newton meter. If we use the velocity as L into N, L is in mm and N is in per minute. So we have 1 divided by minute. And it is mm per minute. So we have to use the value of V is equal to mm. Mm is 600 per minute and we have lead is equal to 12 multiplied by rotational speed N. So 600 divided by 12 is 50. So we have rotational speed equal to 50 RPM. Now we are able to calculate the power, which is given as 2 pi n into TR by 60. So we have 2 pi, rotational speed equal to 50 and we have torque in Newton meter is 39.374. 39.374 divided by 60 is 206.16. That will be watt. The lead screw of a lathe has a square thread of 28 mm outside diameter DO and pitch equal to 5 mm. If nothing is given, then you have to always assume a single start thread, because for single start thread the torque required will be less. We have proved it in one of the numericals. In order to drive the tool carry, the screw exert an axial thrust, that is the W value we have to take as 2.4 kilonewton. Find the efficiency of the screw and power required to drive the screw if it is rotated at 30 rpm. Neglect the friction in bearing, that is the collar friction you have to neglect. Only the torque due to the screw and nut you have to consider. Assume the coefficient of friction of the screw thread as equal to 0.12. So by default you have to assume here a single thread, and therefore we have lead is same as equal to pitch is same as equal to 5 mm. Outer diameter DO is also known, which is equal to 28 mm. Therefore we can calculate the mean diameter of a screw, which is same as equal to DO minus pitch divided by 2. In this case we have DO equal to 28, pitch equal to 5 divided by 2. So 28 minus 2.5 will be equal to 25.5 mm. The screw exert an axial thrust that will take as equal to W is equal to 2.4 kilonewton. Rotational speed N is given as 30 rpm and the coefficient of friction, only the value of mu you have to consider, is equal to 0.12. You have to calculate efficiency, which is same as equal to W multiplied by lead divided by 2 pi into TR. TR you have to consider only for screw this time, and we have to find out the power also. So for power we require TR, we require rotational speed N. Directly rotational speed is given, TR you have to first calculate. This time the torque required will be simply W into dm by 2 into tan of phi plus lambda. First we required here the value of phi. We have tan phi is same as equal to mu, and we have given the value of mu equal to 0.12. Take tan inverse and find out the value of phi. So we have friction angle phi is equal to 6.84. Then we can find out the lambda using the tan of lambda, which is equal to lead divided by pi into dm. We have lead is same as equal to pitch for single start, that is 5 divided by pi, and we have mean diameter is 25.5. So lambda is come out to be 3.57. This information is sufficient to calculate TR. So W is same as equal to 2.4 kilonewton is 2400 into dm by 2. dm is 25.5 divided by 2 into tan of phi, and we have phi is equal to 6.84 plus we have lambda is 3.57. This answer will come in Newton mm. Is approximately equal to 5622, that will be Newton mm. So you have to use the value in Newton meter is 5.622, that is Newton meter. And now we can calculate here the power. Power is same as equal to 2 pi into rotational speed multiplied by TR divided by 60. That is equal to 2 pi. We have rotational speed n is equal to 30. Torque you have to use in Newton meter is 5.622. Whole thing is divided by 60. So you will get a power is very close to 17.66 watt. A very small power is required. And finally we want to calculate efficiency. Efficiency is same as equal to W into L divided by 2 pi into TR. Value of W you have to take in Newton is 2400. L you have to take as 5 mm. So numerator is Newton mm. So denominator should also be equal to Newton mm. So we have 2 pi. And TR you have to take as 5622 Newton mm. 5622 Newton mm. Multiplying by 100, you will get the efficiency close to 33.96%. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.